Hi viewers. So in this video, I'm going to talk about Kubernetes services, particularly Kubernetes services for pods running within a Kubernetes cluster itself. So we'll know what I mean by that in a short while. Let's say you have a couple of pods running in your Kubernetes cluster exposing a REST API or some sort of a service. Usually, when that happens, that particular pod will have an IP address and also you will have a port, which is all good because with IP address and port you can access the service. But usually pods are ephemeral, which means there can be certain conditions which might evict that pod out of that particular node, and Kubernetes might reschedule that pod in another node or even in the same node. For there can be various reasons for that to happen. So in Kubernetes world, we can't assume that a pod will remain in the scheduled node or scheduled space forever. So when a pod gets evicted and recreated, Kubernetes will most probably reassign a new IP address, which is going to be a problem for client application because client applications wouldn't know that new IP address unless it has a way of knowing it. That's what Kubernetes services will solve. So we'll look at that. So what will happen is you will have multiple pods. Again, it would be good if you have a resource in front of those multiple pods, regardless of whether those pods go and come, will be evicted and rescheduled by Kubernetes. If you have a resource that will have an IP address, static IP address, which won't change over the course of the entire uh, time frame, that would be a great way to expose services. So Kubernetes services concept or resource just does that. So let's create a Kubernetes service, and it's another service type, another resource type such as the replica set, daemon sets, stateful sets, and deployments and so forth. So you can create a replica set first and to have the multiple pods. In my previous videos, I've been using this particular image. So I have this thing in place. So let's create this particular replica set. And so in this case, I have replica set as I have shown in the blog post as well. So I'm following my blog post, which I have published a couple of days ago. So I'm following that, and so I will also put the link to that particular part blog in the description section later on. So let's create this. So first of all, let's check if I have any other replica sets. I don't have any replica sets. Now I'm going to create one. Um, yeah, so it should be like this. Replica set created. You see the replica set is now available. So now we should be able to go see the pods. Yeah, pods are getting created. So there are certain other pods that's already completed, which is coming from a Kubernetes job that I have done previously. But the one that you should be interested is this one, because that's the one that's getting created right now. So containers are getting created, and now the containers are running. And yeah, so now each of these pods will have its own IP address and so forth. So now how would a client application want to connect to one of these pods, because each of these pods is exposing a service, and in usual circumstances you would want something in front of it, type of a load balancer, so that it will just forward the request to one of these pods to get the service done. So that's exactly what we are going to do. So to see if there are any other services in my uh, you know Kubernetes cluster, I can issue the svc command or services, right? So there is already a service, a default service named Kubernetes available, and which has a cluster with a cluster IP of 10.96.0.1. And however, I want to create my own service for the pods, 3 pods that I have created, which has a service, which implements a REST API to be frank, right? So let me open this Flask service file. As you can see, it's kind service. So typically you will have replica sets, daemon sets, jobs on a deployment there. And look at, we have given a metadata with the name Flask app service. And this specification says the ports that I am exposing, the port that is exposed out of the Kubernetes, to the Kubernetes service is 80, and it targets the port 5000 of whatever the targeted resource. Now the targeted resource is selected using the selector, which is saying the app type as Flask API. So this is the selector based on a label. So let's look at our replica set. Replica set has a label called app type Flask API. So I'm matching that. So all pods that match this particular label will be part of that services uh, framework, right? So that service will make sure whenever it gets a request into the port 80, and it will just forward that to one of the pods on port 5000. So let's create this service. Apply -f Flask service, and this should create a service. And now if I go back, ask for uh, service, I should see this service, Flask app service and cluster IP. And it has a cluster IP and external IP, it indicates as none because this is not an external IP. And the service that I have created right now with this is just a Kubernetes service. Sorry. It's just a service type. So what does that mean is this service is only going to be available within the Kubernetes cluster. And that's why you will have only a cluster IP. And port is mentioned as 80, which is great. Now we should be able to test this service. In my service, I can say, yeah, well, if I just issue this command, it won't work because I'm outside the cluster. So I should be within the cluster to access this port 80 on this particular cluster IP, right? So this cluster IP is not accessible from outside. You can try that. For example, let's see, localhost port 80, and I have a resource called host, and obviously it says it's not available or whatever. And I think possibly port 80 is taken within my local host, and that's why it's even at least accepting this and saying the particular context API host is not available. It doesn't look like my service, and that's because oh yeah, so it's localhost. I just don't want to access it using that particular thing, so I want to access this particular IP address. So let me try that. Obviously this is going to time out, and the host will be unreachable, so there's no point waiting for that, so it's not going to work, right? And so let's see how to access our service. So now we looked at all this, and to access the service, we need to go into the Kubernetes cluster. So one best way to do that is using the kubectl exe command, execute execute command within a particular pod. So let me just go back and look into one of the pods. So we need this pod name. So I'm going to go into this pod and then use this dash dash command to say I'm going to execute this particular command within the pod. When you do that, you see the request is going through, and you get the host name. So that's what this particular context is for. You can run it again to see what happens. And yeah, so you got the host name here and happen to be the same host name. So it's going back. And now you see the host name is different, right? So it's getting back the response from this. Earlier it took the response from this twice. So when you hit it multiple times, you will hit it into different pods, because this particular service type, the cluster IP service type, will only do one task. It will just make sure select one of those pods randomly and forward that request. And there must be some sort of an algorithm within Kubernetes which we don't need to worry about, and so forth, right? But this can be overridden. I mean, if you want to have these requests forwarded to one particular pod always from a particular client, so you can use this session affinity uh, property within your spec object. So I'll leave that as an exercise for you, so you can do that there. Fine. Now we have an IP address, a static IP address that will not change. So which you can also check. For example, let's do this, and um, I'm going to restart a pod, or maybe delete pod. Now when I do this, this pod will get created once again. For example, the pod is getting created. That's because of the replica set. Because replica set says my desired state should be 3 pods running always. Now you have the pod. Now I can issue the same command here within that. Okay, so that pod is not available. So yeah, I'm going to use another pod now. Right, and it should give me back the response, and even forward that to the first one. Sometimes you should be able to see. Yeah, so this particular request forwarded to the newly created pod. So how did this particular service knew about that pod? So that's what the magic of Kubernetes is all about. And this particular IP address never changed, even though I restarted this particular pod. So it will be applicable even if you restart all of the pods. Right. So that function is clear. Now let's talk a little bit about service discovery. IP addresses are great. So you have, like, all of us love to work with IP addresses, right? And however, it's not very human friendly, even though we like to work with it. We like to work with names better, because those names are much more digestible, and we can remember those names and so forth. So if we can have a name mapping for our IP address, that would be great. And this is usually the domain of DNSs, domain name service. But Kubernetes offers two ways for client applications to know about the service of a particular service, right? So how would that client know the IP address? Either it has to wait till the service is created and then get to know about the IP address and then hard code it somewhere in the client application and so forth. Not ideal, right? So a better approach would be whether the service is created or not, before the client makes the request, it would be great if the client could know or have a way to access these services. So one way Kubernetes provides that capability is using environment variables. So for example, now let's go into the same pod and issue this env command. Now in my pod, I just forgot to mention one thing. I had curl already installed. If you didn't have curl installed, and you would have to install curl, and that particular installation will disappear in case if you evict your pod and recreate it, right? So in this particular Docker image that I have installed curl so that it makes my job easy here and so forth, right? So in case if you don't have it, you will have to install it before doing that. So if I issue the env command, um, yeah, yeah, I'm not seeing that. Let me see why. Um, Probably it's because, let's see, we'll get the pods again. Let's try to see this one. Yeah, I have certain details, especially because I created this pod after the service was created. Anyway, I have these details. So the environment variable has something called Flask app service underscore service host, which points to my service. So let's try to get the service to see if it's the same. Yeah, it is the same IP address. So we can use this particular environment variable. So let's try to do that. So first of all, I would like to get into this pod and yeah, I would like to use this to get into the so this command will get you into the pod uh, bash. So okay, something went wrong. So typically this issue is happening because when I copy this, I'm missing this double slash, and make sure that you always have that double slash. Otherwise, Kubernetes is going to understand, or kubectl command is going to understand that as something different, right? So make sure that it's accordingly happening. But again, I made a mistake. So again, it's not get, it's exe. So when you do that, now you are inside the pod and inside the command prompt of that particular pod, which is great. So now I'm going to access my service using for example, if I use this, the environment variable, I should be able to see the IP address, which is a great way to know the IP address. Rather than remembering the IP address, you can use this particular environment variable. How this is constructed. Now, Flask app service is my service name in lowercase when I created it. So you had to uppercase that and then have this appended underscore service host all in uppercase. So now I should be able to call my service using that. In your applications, of course, you can resolve it, but in curl, you can do it this way. And when you do that thing, you get the host name, which is a great way. So that's one thing. The other thing is Kubernetes also provides a DNS. service which provides a fully qualified domain name for your services, right? So in cloud-based Kubernetes providers, have these DNS services, installed and enabled. And in your case, if you don't have it, especially if you're running this on Minikube, right, you will have to enable it. So I have enabled those things, and so otherwise you can just list it down in your Minikube. Let me go back here. And you should see whether DNS related services are enabled or not. So for example, in my case, I have these DNS services enabled, and if not, just enable it for yourself, right? So you can enable it using Minikube add-ons enable and your add-on name. So now let me call this particular thing first to see if it's working. It should be. For example, if I do this, now you see I'm issuing a quite a name here. Again, there is a naming convention. Flask app service is your familiar name, Flask app service. And then I have appended dot default and dot service cluster local, right? So this is the way that Kubernetes creates the domain name, fully qualified domain name. So actually default stands for the namespace where the service is hosted. In my case, it's in the default namespace. And service cluster.local is something configurable that you can change it according to that your wish for that particular cluster. So normally by default, Kubernetes gives this particular name. But if you're calling your service within the same cluster, you can simplify this. Of course, you can remove this because cluster knows what it is. So it should still work. And also if it's in the same namespace, right? And if it's specifically if it's from if your client application is in the same namespace, you can also remove this, and this will also work. Fine. I think that's what I wanted to cover for today in terms of Kubernetes services, especially exposing Kubernetes services to expose services of other pods to be accessed within the cluster itself. And of course, there are other ways that Kubernetes services can be used for. For example, to let client applications, external client applications access the Kubernetes service. So we'll talk about that in another video. And also Kubernetes services concept can be used to access services which are outside the Kubernetes cluster. So yet again, we'll be talking about that in another video as well. Thank you for watching my video on this, and please subscribe to this channel and click the bell button to get the notifications, and have a great day. Thank you very much.